All right, we're live, and we're gonna do we're gonna work on we're gonna continue with the Rust book, and I think we are looking at tests, right? So previously we did Rust links, and we took care of generics and a bit of lifetimes, right? With traits, yeah. So we did Rust links on those parts, and now I think we can do automated tests, right? So we're gonna learn about tests here, chapter 11 here. I don't know for how long we would be able to do this, but let's do this. So I would like to create a project, right? So let's create a project for test, and um, let's create a new project for test. I'm just gonna call it test. Yeah, the test project, and um, yep. Oh no, I think we. Sorry, I think we should actually get into the project, the test project. Yes. And now we can do this there. Yeah, now we are in the correct place. Okay, so fun stuff. I was working on. Maybe I should share. I should mention this already. Yeah, fun stuff. I was working. I think over the weekend on a project. I mean, I was trying out some features of Rust, right? So basically, I needed to do some processing of like a video stream and I wanted to work with this tool. It's a workflow orchestration engine. It's Temporal, Temporal.io. This is it. There's also the open source and the cloud um, version of it. It's workflow orchestration. So basically, you can do distributed processing of like tasks and stuff, right? So it helps you with mostly if your machine dies or the server goes off, right? So the work is already on temporal and then it will retry and stuff like that. So it's basically workflow orchestration. I think that's what they also say here. So there are other different tools I can use, just that I've used temporal and I think I sort of like the way it works. Like I'm also very used to to how it behaves, Um yeah, so that's part of what I wanted to use for this thing I was doing. But then in Rust, they don't. So the Temporal, for example, has like SDKs. They uh have their own database, right? So they use the Postgres DB to store the the workflow data, right, itself and stuff like that. And they have SDKs in Go, as you see, in Java, in PHP, and the rest. But they don't have any SDKs in Rust, right? And and I mean that's so for me. I was like, wait, so how do I work with this? Part of why I needed Temporal was also for I mean they have this nice UI. They have I think I don't know if I can they have a UI. I don't know if I can show it here, if I can yeah, they have a UI that allows you to see or to like see what's going on with your workflow and stuff like that. And then I found that they have um they have a core SDK, they call it. And that core SDK is actually in Rust, so built in Rust. So it allows you to communicate with Temporal via gRPC. And I started to do that. So so basically I said, okay, you know what? I already started to do what I was working on in Rust. I would just um I mean I had options anyway. I could have tried to use any of the other SDKs, right? And then communicate with that via I think they call them foreign functions in Rust, right? So I think that would be via unsafe code, but I didn't want to do that. So instead, I said, okay, you know what? Since it has gRPC, the SDK itself, I think it's like uh temporal. I think it's in it. Yeah, the SDK, the core SDK itself. Yeah, it's written in Rust. um, and uh, you communicate via via gRPC, right? So I had to do that, and it was fun, right? It was fun. So I'm just talking about just recounting fun stuff I worked on. I will probably be sharing that maybe after a while. Maybe I'll also even work on that on the live stream at some point, right? So in Rust, it was really cool. I also got to start working with um, tracing libraries in Rust and stuff like that, and that's pretty cool. So, so I think we already got over the basics. That's what I see so far, right? So getting to that level, but I haven't yet integrated a database into it. But that should be pretty easy to do anyway. Yeah. Okay. So let's come to it. We're not doing a stream on on durable execution with Temporal right now. So we're gonna do tests, right? So let's go over it. Yeah. So it's on writing automated tests. So what in his 1972 essay, The Humble Programmer, Edska Dishka, whatever it is, said that program testing can be a very effective way to show the presence of bugs. It's actually not, yeah, the absence of it, but it is hopelessly inadequate for showing the absence. Exactly. I don't think maybe we shouldn't try to test them as much as we can. Correctness in our program is the extent to which our code does what we intend it to do. Rust is designed with a high degree of concern about the correctness of programs, but correctness is complex and not easy to prove. Rust's type system showed us a huge part of this burden, but the type system cannot catch everything. As such, Rust includes support for write automated software tests. Okay. Say we write a function add two that adds two to whatever number is passed through. The function signature accepts an integer as a parameter and returns an integer as a result. When we implement and compile that function, Rust does all the type checking and borrow checking that you learned so far. Yeah, so far you learned that, for instance, we aren't passing a string value or an invalid reference to the function. But Rust can't check that this function will do precisely what we intend, which is return the parameter plus 2, rather than say parameter plus 10 or the parameter minus 50. That's where test coming. We can write test that assert, for example, when we pass 3 to the add function, the value returned is 5. Uh, we can run this test whenever we make changes to our code um, to make sure any existing correct behavior has not changed. Testing is a complex skill, although we can't cover in one chapter every detail about how we write the test. In this chapter, we will discuss mechanisms of Rust testing facilities. We'll talk about the annotations and markers available to you when writing your test, the default behavior and options provided for running the test, and how organizations, blah blah blah. Okay, I don't know. I feel like I should actually just do this myself. I'm maybe not even be reading it out. But let's see. How to write text. Yeah, so basically, I think this is generally the way tests work, like in different regardless of the language, right? Or sorry, the programming language, or the tests are basically Rust functions that verify that the non-test code is functioning in the expected manner. So the bodies of test functions typically perform these three actions: set up, the needed data or state, run the code, and the test assert. So that's it. Yeah. So let's look at the features Rust provides specifically when writing tests that take these actions, which include the test attributes and a few macros, and the should panic attributes. What anatomy of a test function? At its simplest, a test in Rust is a function that's annotated with a text attribute. Do you mean okay? Okay, test attribute, not a macro, it's an attribute. Attributes are metadata about pieces of Rust code. Yeah. One 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 example is a derive attribute, which we used with struct in, mhm, in chapter 5. To change a function into a test, add um, the hash and then test attribute on the line before the function. Okay. When you run your test with a cargo test command, Rust builds a test runner binary that runs the annotated function and reports on whether each test function passes or fails. Okay. Whenever we make a new library project with cargo, a test module with a test function in it is automatically generated for us. Yes. This module gives you a template for writing tests. So you don't have to look up the exact structure and syntax every time you start a new project. You can add as many additional test functions as you would want. We explore some aspects of how tests work by experimenting with the template before we actually test any code. Then we write some real world tests. Okay. So this is okay. So um this is a test. I don't know if we can. We didn't create a library. We didn't create a library. We didn't create a library with Rust. We created this is a binary creator right now. But let's see. I mean, I'm sure we can actually. Uh, I think we can. Yeah, we should be able to do this. Let's see. Sorry, I'm going to do use. We actually need to look up the syntax anyway. So if we had a function called um, I don't know, add maybe, and then this is I just say a, and then we have a function say that says I don't know if I don't know the convention in Rust, right? We have this should in other places. I'm just gonna say should add, and then we can use add, right? So we can even put this in the model. Um, Yeah, I can put this in a module, for example, and then here, because I already bring in, I already import everything, so I can use everything here. And then I can say should add operation. Oh, wait, I can't get access to it. Maybe I need to make it public. Is that it? Yeah, okay. Even though it's in the same, even though it's in the same, it's in the same file, right? But anyway, I can say add and I can say 5 and 9, maybe. Yeah. Um, so I can say let the result maybe be that. And then hey Leo. Hey, how's it going? Exactly. Yeah, yeah. I hope it's good. Hope all is good by you. Yeah, all is good. Yeah. Yeah, I was good. We've been doing rustlings before, right? So, but now we want to look at testing here. I think we have this assert equal macro. And one thing I was looking at with the assert equal, so it would be result and 14. But the thing is, assert the assert equal doesn't exactly uh wait, okay. I think I think I okay. Yeah, the assert equal doesn't yeah, okay, I was trying to bring up this. It doesn't no normally in other frameworks, I think you would have expected and actual, right? So normally, but this I don't see that it says it just says that assert two expressions. And how does it I mean, I guess you can pass them in any order, right? I want to confirm that. So here, maybe if I go to the standard reference and I say assert equal, this is the standard crate, yeah. The macro for assert equal just asserts two expressions, left and right, and that's it. That's it. Like it doesn't. It's just the both of them. So you don't have to. Yeah, I know. In the test framework that Java has, right? Is it Makito? Which one it is? Where you have to. I mean, you have to say which is the. You have to keep in mind which is the expected and which is the actual. But this one you don't have to bother about that. Okay. So when we have this now, we can actually run this by doing. By the way, this test is not going to run yet. Yeah, JUnit exactly. I think it's JUnit, right? Um, expected actual order. Exactly. This is some of the quirks, right? You have to keep in mind it's assert equals exactly. And then the order matters. You see, why would I have to bother about something like this? I don't want to I don't want to care about something like this. You're right. Yeah, you're right. In Swift, if you mix them up, you will get a weird error. You see, like yeah, exactly. Even with JUnit, if you mix them up, you could actually have your tests behaving weird. Exactly, your test will behave weird. And yeah, so when I was using assert equal, I was like, wait, do I have to keep that in mind? But here you don't have to, which I quite like. Okay, so let's run this. I think you have to run test. Is it cargo test? I think it is. But this won't run yet because there's no test to run. So we have to include the attribute here and say test. Exactly. And now, yeah, now it picks it up and we can now run this test. Yep, that's it. So what if we say this was like 13? Oh, wait. Um, oh, yep, 13. I want this to fail exactly. Okay, so this is how you behave. Nice. By the way, not to okay, well, I was gonna show you something, Leo. I was also I think at the beginning of the stream I was talking about beginning of the stream I was talking about how that I was working on something with gRPC with Rust, and it was really cool. I was trying to work on Temporal with it, and Temporal doesn't have an SDK for Rust. They only have for like Go, Java, and TypeScript. And they have yeah. No, I was talking about I mean, I'm talking about like cool stuff. Like I started to look into at least more capabilities or more things. So over I think it was over the weekend, yeah, I was looking into working on something. I was working on something that needed me to do durable execution. And I thought, okay, maybe I could do this with Temporal. And I saw that they don't have Rust SDK. Yeah, they don't have Rust SDK, but they have like um yeah, they don't have Rust SDK, but they have so I needed to do durable execution. My options were well good. Yeah. My options were I could just use like the Rust async with Tokyo. So Rust has this, for example, with Tokyo. Um, but but that was not exactly what I wanted. I mean, I have to manage the stuff in a database and stuff like that. But I wanted to have some workflow execution that also had its own UI and stuff like that. So I wanted to use Temporal and the SDKs, for example. You see, they don't have Rust. Is there interrupt of Rust with something that has support? What I found is that they have they have this they have an SDK. They have a core SDK, they call it. So this core SDK is pre-released. That is, they haven't yet had a even a first release with it of this one. This is written in Rust. So this is in Rust. However, it's the core that is the base for the other SDKs. All right. So basically, this one is this one actually talks to the core of their temporal stuff, like database and all of that stuff. Yeah, exactly. Here's that they don't provide one for us. Yeah, yeah, exactly. So what I found is that with this one, with this their core SDK, you can actually use it directly, right? But you have to you have to use it by calling gRPC services, right? So you'd have to call gRPC services with it. Or the other option I had was I could use any of these SDKs, but I would need to call like to like you were talking about interrupt, right? So I would need to maybe use foreign functions, right? So to access external code and the rest. I didn't want to do that, so instead I said, okay, I was gonna talk to this with gRPC, and that was what brought me brought me to gRPC. I think it was yesterday. So I could show you what I'm talking about. All right, do I have let me show you that piece of code. Is it? I think it was it's this one. So this is what it looks like. This is what it looks like. So basically, we have so this is the so it also made me start thinking about a lot of things, right? So I have I have a library. This is the library itself, and I mean, initially I started off having the protos inside of the library, but later on I started thinking I'm gonna move out the protos so that everyone can use it, right? But then, so just right now I have the protos here, so I have just one proto file, right? Which is this one, yeah. And then I needed way Rust, so I also got into the whole build cycle of Rust, where you need to have a file that manages the build for you. And when you compile your code, when you compile your code, it will also build this into the code, right? Into the to build the code, the client and server for you, depending on what you want, right? So yeah, so that's so I started to work on Protos here. So that's interesting. Well, that was interesting for me as well. And then I think I had, what else did I even have? Yeah, so I have a couple of libraries here. I try to organize stuff. It's not what I want yet, but at least I have something, right? So I have just one function. I mean, I have a function that basically does what I want, and this is good. So this library itself is used inside of the server, right? So the server itself is now the gRPC server, right? So this is what the main function looks like, right? So it's a regular. I'm using Tokyo here, and it has like I mean regular Tokyo code, right? But what it does here is that it uses the service, so the gRPC services that were built, right? It's gonna use them now, and that service is the video server here, which you see. So this video server is now going to be used here. So the video server is used here, and this video server itself is actually even under my services. Oh wait, I added it as a module. So yeah, just a sneak peek of what. So basically, my point is that I feel like we're making some progress, right? With these learnings that we're doing here. So like, I wanted to dabble into some stuff that I felt was pretty decent, right? So something, yeah, and I think it's coming along well anyway. Yeah. So I mean, there's some learnings. I also got to configure both buff, and also like even configure ending to handle like buff and handle the stuff. So yeah, it's pretty okay. And yeah, the I think this also runs fine if I'm not wrong. And I think I had, yeah, I also added reflection to it. Yeah, so he said, happy to hear. Had you used gRPC before with macro repos? Um, okay, with macro repos. Um, I'm not sure. I'm not sure how you mean. I'm not sure. Is this a macro repo really? I mean, I don't really feel like this is a macro. Okay, yeah, this is sort of a macro repo. Yeah, macro repo is like before we introduce it. Oh yes, yes, yes. Previously, yes, yes. Yeah, I've worked on. I mean, I think that was sort of how I used to work at some place before. Yeah, and yeah, yeah. But for this one itself, I mean, this is just a library. There's no executable here in the afterclass itself. And for the server, this is the one that actually has. I mean, the CLI has an executable. Yes. Yeah, you're right. Actually, there are multiple. There could be multiple executables here. The one that runs right now is just this server. And if you look at the cargo table file, you notice that we are using we're using the library, the Aftercast library here. Yeah, and I think uh, wait, yeah, exactly. So I have to run the server separately. Oh, address already in use. Okay, I think I was running this previously. Um, 5051. I mean, I don't want to. I could kill that now, but let me just change the address now. And yeah, okay. Yeah, so we have it running, and if we even, I think it was like, for example, you'd see. So yeah, we have reflection for this um, service itself here, and yeah, I mean that was cool. So so that was it. I mean, I was just trying to show to show that to show you that I think I think it's I think it's sort of coming together, right? So we're able to do something. We'll be able to do something that could be substantial here, actually. Yeah, and I mean even with organization and stuff, move stuff around. So yeah, that's for that one. Yeah, so I come back to our test here. So our test works, and that's it, I think. Yeah. Okay. Sorry for my digression. I went on a rant, but I think it was quite exciting anyway. So I think that's what I was also thinking whether I should maybe also stream that those things. So right now we're just streaming the learnings we're doing from the Rust book, but maybe it might also be fun to work on that project live, you know? I'll think about it. I'll consider it whether I'll do that. Yeah. Okay, so we have the I think they also use the assert equal here, and that's it. Um, so so now the file lets us add this. Yeah, we saw that. For now, let's focus solely on it works. Then we should note that the test annotation, this attribute indicates that this is a test function. So the test runner knows to treat this function as a test. We might also have non-test functions in the test module to help set up common scenarios. Exactly. Okay, or perform common operations. So we need to indicate which functions are tests. Okay, so that's how hmm, with like JUnit and stuff, I think you would have a setup. You would have setup function. I think JUnit. Yeah, setup. You have setup and tear down. That's how they work. And yeah, this is the JUnit guide. Mm, come on. Okay, you also annotate with test anyway, but they also have like setup and tear down functions for those ones. If you just compare, yeah. So okay, they also use annotations. Those ones use annotations, but okay, that's before all and after all or after each. Okay, but I think there's also the ones that have like setup. Which ones use setup? Is it JUnit? No, or is it Mockito? Setup method. Okay, yeah. You okay? But anyway, I think you get the gist. But here in Rust, we would just be able to um, use a regular method as long as it's not annotated with the test attribute, and we'll be fine. Okay, so let's see something else. The example for the example function body uses assert equal macro to assert that result contains the result of 2 and 4. The assertion serves as an example of the format for a typical test. Let's run it to see how it passes. But we already did that, yeah, okay. So cargo compile and run the test. We see the line running one test. The next line shows the name of the generated test function, test it works. So which was like, so you did a compile test, and then yeah, so when it compiled it to the target and a particular binary, and then that's what it ran. Then it ran that particular test. Okay. And the result of that running that test is okay. So yeah, how do you deal with async coding tests? Um, that's actually a very good point. I actually I haven't written any tests so far for async code. I mean, normally with async, you would you it was like you would await. uh you I mean regular when you write an async code, normally you would await um hmm, in tests, what would you I mean I haven't there's a section on async code, async code here. I think it's in configures concurrency, fundamentals of asynchronous, async await. I think this section, chapter 17 here, would probably have some details on that. Yeah. I mean that would be interesting actually. I think I would actually check that. I'll check it because I actually have in that other code I was showing now, I mean I've written like some functions with async code, but I just haven't written any tests yet for them. Yeah, I would check that actually. That would be really, really nice to see. Yeah. So I can check that. So yeah, I'll check that and maybe I think maybe later today. Okay, so it says it's possible to mark or, I mean or if you have like ideas, I mean it would be the same way you do with async code in any other framework. It doesn't have to just be Rust, right? So yeah, I guess you could test their side effects maybe. I mean if your async code is doing some side effect stuff, right? You could you I mean that comes to mind already. But yeah, you can check that. So it's possible to mark a test as ignored. So how do you do that? So it doesn't run in a particular instance. We'll cover that in ignoring some tests. So a separate section later in the chapter. Because we haven't done that here. The summary shows zero ignored. Okay. We can also pass an argument to the cargo test command uh, to run only tests whose name match a string. Okay, that's called filtering. So we'll cover that part. So we haven't filtered anyone, so it says zero filtered out. The zero measured statistic is for benchmark tests that measure performance. Nice, nice. I mean, I like that this part comes with cargo. It comes directly as part of the Rust compiler. Yeah, because you don't have to import anything else or to do benchmarking and all of these kind of things. This is really nice. Yeah, I mean, in some other languages or some other languages, such things come as like external libraries. But I like that this is part of it. So benchmark tests are, as of this writing, only available in nightly Rust. Okay. The next part of the test output starting at doc test adder. Hmm. Is for the results of any documentation tests. We don't have any documentation tests yet, but Rust can compile any code examples that appear in our API documentation. This is also something I really also like with Rust. Uh, the fact that the fact that documentation is is first, like it's an afterthought, right? It comes together with cargo. So like the code I was sharing earlier, I wrote like a little bit of documentation with it. I mean, not a lot, just I just wrote some comments in my code, and I was able to generate documentation. I mean, like I could generate document documentation for my library that was ready. It was like production ready. There was nothing else I needed to do, And I think that's really cool. Also, that's really super cool. Okay, and there's also like doc tests. So we don't have any documentation tests yet, but Rust can compile any code examples that appear in our API documentation. This feature helps you keep your docs and your code in sync. This is really cool. We discuss how to do that later. Okay, that's fine. So now let's start to customize our test to our needs. First, we change the name of it works function to a different name, such as exploration. So you want to change that to exploration, okay? And then what? What else do you want to do? Then you run it again, and cargo will shows exploration instead of test. Okay, that's pretty basic. Yeah. So what else? Next, we add another test, but this time we'll make that test fail. Test fail when something in the function panics. Each test is a new thread. Okay. And when the main thread sees that a test thread has died, the test is marked as failed. Okay, in chapter 9, we'll talk about how the simplest way to panic. Okay, in chapter 9, we talked about how the simplest way to panic is to just call the panic macro. Enter the new test as a function named another. So your library looks like this. So, okay, so we just panic. So, and it says this test is a new thread. So how does that work? So you're going to run the test and then you see. So after compiling, then you have running two tests. And this is what it's going to do. Yeah, because it also says here thread. So that is one thread. That thread panicked. So it marks make this test fail. Okay, I mean that's what we printed. That's what we panicked with. Okay, interesting. So basically, if I have another test, what did I see here when I was running this? It actually said thread. So this thread was this is one thread. This is the yeah, okay. Okay. What if you have like 20 tests? Okay. Mm, new sections appear between individual results and summary. The first displays the detailed reason for each test failure. In this case, we get the details that test another failed because it panicked. Yeah, but yeah. Okay. I don't think there's much more we need to see. Let's go on. So checking results with the assert macro. Okay, this is also is interesting. So you have you have a struct and you have the implementation, which has one function can hold, actually method can hold, and then you use the assert macro, which is part of the standard library. You want to ensure that this condition is true. Okay, of course. Mm. If the value is true, nothing happens and the test passes. The value is false, the assert macro panics. Yes. Okay. So where's the test? The test is larger can hold smaller. And then you create a larger rectangle and a smaller rectangle, and then you do a can hold. And then you just use assert. Yeah, okay. So I think what is important here is just to know that we can use assert equal and assert, which is just true. And then what else? Let's go on. So we notice they use super, which brings everything in a function into scope, right? Inside the test module. I mean, basically, I mean, I've gone through this before. What's different? What's different between assert and assert equal uh to true or false? So the assert function, the assert function takes I mean, it takes a results, it takes a boolean there, right? So whatever you pass into the assert macro, actually, not function, whatever you pass in the assert macro has to resolve to a boolean, true or false. But assert equal takes two what do I even call them? Two I was gonna say generics, right? Two values really, yeah, two values. They can be any values at all, and compares them, right? So they have to, yeah, they have to. So if, for example, if you check this, you see that I said equal. Okay, right, yeah, expressions, yeah. This so you have left and right, and then it would um compare the both of them, right? So, but the assert itself takes the assert macro, yeah. So it asserts that the Boolean expression is true. So you pass an expression to it exactly. They are the what you pass to the assert macro itself is going to be an expression. But the other one, left expression, right expression. So okay, assert two expressions. Yeah, because they can actually resolve. Yeah. So yeah. hmm Okay. So yeah, so there are two. One of them is just a single expression, and the other one is it takes two. So I think that's the difference. Assert takes one expression. Assert equal compares two expressions. Yeah, that they are equal. Yeah, because the test model. Yeah, so the test model is a regular model that follows the usual visibility rules we covered before. Because the test model is an inner model, we can bring the code under test in the outer module into the scope. And we use the glob here. I think the glob is what you mean by this, yeah. So anything we define in the outer module is available to test mode. Okay, I think that we know about. So basically, what they're talking about is this. So when we use super and this, it brings everything we have. I think we also use that here. So we have a module here, and then we have this function in the module itself. And then when we do super this, what we're doing is we're bringing everything that is um, here, making them available in this other module. Yeah. So I think we got that part already. What else? But we don't have to use this anyway. We can still use create. I think we can do use create operation. Yeah, we can do this if we want. We don't have to do this, but we do this, we already have everything, and then there's no need to bring each item since it's just for tests. Yeah, but for code, it's better for us to do that individually. Yep. So and then I was saying we've named our test larger can hold smaller, and we've created two rectangle instances that we need. Then we called a set macro and passed it to the result of calling this larger can hold smaller. This expression is supposed to return true, so our test should pass. Let's find out. And okay, yeah, the test passes. It does pass. Let's add another test. So I want to write this function, right? So let's write this. I mean, because um, we have to practice this, yeah. So let's have a I don't know, maybe we can. There's probably no need to have this. Okay, so let's have a struct rectangle, and we have a width. I don't know, U32, or maybe U64. And we have a height, U64. These are rectangle, and then we can have an implementation. We can implement rectangle, yeah. And here we can have a function can hold. I think that's what they call. Yeah, can hold that takes self and takes a reference to and takes other, I guess something like that, right? And then it's also a reference to rectangle, or maybe is it? Yeah, could be a reference to rectangle, yeah. And then this should return us if self dot width is greater than other dot width and self dot height is greater than other dot height, then can hold will be true. Yeah. Yeah, this doesn't return something, so it needs to return oh wait, no. Um Yeah, okay. So this has to return bool. Yeah, it was fine. So now we have this, so we can have the test for it here now. So now in our test, we can, I think it was gonna be uh, larger can hold smaller, something like that. Yeah, yeah. And then in this function now, in this test function, we can say we can create the rectangle, right? So we can create a larger. Oh wait, come on. Why are you hanging? So we can now create the let larger rectangle, or maybe I should say, yeah, exactly. Larger rectangle should be rectangle, and we pass the width of 50 and the height of 30, right? And we have this rectangle. Then we pass let smaller be a rectangle where the width is 10 and the height is 20. And we have two rectangles. Now we can say assert. Yeah, we can use the assert macro itself. This takes an expression, assert that larger dot can hold, not smaller, but a reference to smaller. Yep. hmm And now we can test this. Yep. So result is okay. So this is fine. Okay. So this is, I think, yeah, we get the concept, but then they wanted to add another function or another, what they said, uh, can hold method returns a Boolean, which means it's perfect use case for the assert. We want to write a test. We write a test, or rather in listing 11.6, we write a test that exercises the can hold method by creating a rectangle. Um, okay. I think we've seen all of this, right? We've seen all of this. So they wanted to add a new test. I think that's what they wanted to do. Yeah, so they wanted to add a new test. Smaller can hold larger, which would give you a false, I think, right? So larger can hold smaller is fine, but of course, oh wait, look at what they did here. So they did the assert macro. Yeah, yeah, okay, cool, cool. Thanks, Leo. Uh, thanks. Have a good evening. Have a good evening yourself. Yeah, yeah, all right. See you. Okay, so we're gonna, what they did is they did the assert macro and then they use a negation. Okay, actually, I don't, I mean, is there another, but there's also the negation macro, yeah? So we don't have to do that. So basically, we can have another test that says smaller can hold larger. Is it can hold or cannot? Yeah, I think I should say cannot hold larger. Yeah, something like this. Yeah, and basically, I can copy this out and paste them here, and then I can say assert negation, right? So I said the two expressions are not equal. Okay, that's negation. Hmm. Okay, assert negation takes two expressions. Okay, yeah, but how do I? Okay, well, I guess it doesn't make much sense for them for us to have that. So you would still use assert, but then you're gonna say smaller dot can hold reference to larger, and then you say assert that this cannot happen. And we then need to have the test the test attribute here, and then we do a cargo test. Okay, okay, all right. I mean, let's look at I want to see what this is prints out for us. What it prints, it does compiling first. So it compiles this. In fact, wait, I think I want to see. Oh, wait. Hmm. Okay, well, I mean, it compiles this. Yeah, and then there it is, running unit tests here. Okay, well, anyway, yeah. So to test pass, let's see what happens to our test results when we introduce a bug. So if we introduce a bug, this is the bug we introduced here anyway, and then it's now going to produce something that looks like this. So this is going to fail, and you have the failures. It shows you the failures. Our test caused a bug because this. Um, I also want to see what this. I mean, I've seen this, but I'm also curious, right? Yeah. So what happens is it tells you running two tests. Yeah. Smaller. So it shows you the test. So smaller cannot hold larger passes, but larger can hold smaller field, and then it shows you the failures. It prints them like this. So you have the test, and then the one that panics tells you where it panicked at line 32. Okay. Okay. And then okay. It shows you where it panicked, and then it tells you yeah, so what fields, session field, and you then see this. Okay, that's fine. So you can test the quality with assert equal macro and assert not equal macros. Okay, I think we already looked at this one. A common way to verify functionality is to test for equality between two results of the code under test and the value you expect it to return. You could do this by using the assert macro and passing it an expression using the equals operator. Okay. However, this is so much common that the standard library provides a pair of macros, assert equal and assert not equal, to perform this test more conveniently. These macros compare two arguments for equality or inequality respectively. They also print out the values if their assertions fail, which make it easier to see why the test failed. Conversely, assert macro only indicates that it got a false value for the expression equal without printing the value that led to false. Okay, makes sense. Um, So we write the function that adds two. I think we started with the add two previously. Oh, okay, I think we took it out. Yeah, we started with that one. And then yeah, we do this. Okay. So basically saying when you introduce a bug into the code, it looks like this. It tells you assertion left equals right failed, and tells you what's left and what's on the right. Okay, which is cool for you to see what's happening. Our test caught the bug and tells us the message tells us that the assertion failed, was left equals right, and what was left and what was right. The message helped us start debugging the left argument where we had a result of calling add to was fine. Okay, that's fine. Okay, note that in some languages and test frameworks, the parameters to equality assert functions are called expected and actual. This is what I was saying before, right? At the start of the stream, I was saying that some other places, I think these J units we saw, right, would to be expected and actual. And the order in which we specify the argument matters. Yep, we said this. We actually said this. However, in Rust, they are called left and right. They're called left and right, and the order in which we specify the value we expect, and the value the code produces doesn't matter. Whoa! Okay, this is really cool. I love this. So yeah, we were right when we said this, and now they also wrote it here. So this is really cool. We could write the assertion in this test as assert equal for and results, which would result in the same message failure message, sorry, which would result in the same failure message that displays assertion left equals right fails. Yeah. Assert not equal macro will pass if the two values we give it are not equal and fail if they are equal. The macro is most useful for cases where we are not sure what a value will be, but we know what the value definitely should be. For example, if we're testing a function that is guaranteed to change its input in some way, but the way in which the input is changed depends on the day of the week that we run our test. The best thing to assert might be that the output of the function is not equal to the inputs. Yep. Under the surface, assert equal and assert not equal macros use the operators equal and not equal, respectively. When the assertion fails, these macros print their argument using debug formatting, which means the values being compared must implement partial equal and debug traits. So that all primitives and most of the standard library types implement these traits. For structs and enums that you define yourself, you would need to implement partial equal to assert equality of these types. You will also need to implement debug to print the values when the assertion fails. Because both traits are derivable traits, as mentioned in the previous listing, this is usually as straightforward as adding, nice, as adding the derivable traits, okay? As adding the derive partial equal debug annotation to your struct or enum definition. This is so cool. So, I mean, I was already thinking about testing this, like trying this out here with, hold on. I was already thinking about trying this out here with the struct. And I was like, wait, maybe I'm probably gonna need to do derive debug, right? So I think you can do debug, and in this case, we have to do partial equal. Yeah. So if we do this, and um, we say in the test, we say, wait, I want to first remove it. And then let's have a test case for, no, I don't, no. Um, so, um, wait, sorry. Okay, and then let's try to say assert equal, larger, smaller. Binary operation. I mean, I want to see what the error we get. Binary operation equals cannot be applied to type a rectangle. It doesn't say why. Okay, it does say why actually. So it tells you that a rectangle doesn't implement debug. It tells you it doesn't implement. You will also see what about the partial equal? I mean, I see that it's a hint for us to do it, but it doesn't. It's not an error here. It's just so let's do that. Let's use debug and see. There. Okay. Still tells you that it cannot. Binary operation equals cannot be applied to type rectangle. Hmm. That is interesting. Wow. So if I don't have partial equal, the error I'm gonna get doesn't tell me. It's not very helpful. Like okay, I mean, it's like binary operation equal cannot be applied to rectangle. That's it. Hmm. This is all you're gonna get. But then the hint, gives you a hint that an implementation of partial equal might be missing. Well, at least it does. At least it does give you that hint. So yeah. Okay. All right. That's fine. And then what? And then we have like the test assert them, both of them. Uh let's run this. I think we want to wait, no. I think no, instead we want to do change this back to being fixed. And then one is gonna fail. Or rather one should fail. Yeah, two pass, one fail. So it tells you, so that left and right, you see left equals right failed. Left is like so. So yeah. So because it needs to be able to print, uh, use print using the debug trait, right? Printing debug. That's why it's able to print the entire thing here, and because it implements debug. Okay, so it tells you what's on the left and what's on the right. Okay, that's fine. And then uh, derivable traits is something that maybe we can check this later. Actually, I think what are the variable traits? I want to just see. So in various places in the book, in this book, we've discussed the derived attributes, which you can apply to a struct or a definition. The derived attribute generates code that will implement a trait with its own default implementation on the type you've annotated with the derived syntax. That is so cool. I would like to actually see this code. I mean, we can check it anyway, right? So the derived attribute generates code. So that's going to be a code generation that will implement a trait with its own default implementation. So in this appendix, we provide a reference of all the traits in the standard library that you can use with derive. Each section covers, where is it by the way? Okay, it's just here. Yeah, it's fine. So um, each section covers what operators and methods deriving this trait will enable, what the implementation of the trait provided by derive does, what implementing the trait signifies about the type, the conditions in which you are allowed or not allowed to implement the trait, examples of operations that require a trait. If you want to, if you want different behavior from the provided by the derived attribute, consult the standard library documentation for each trait for details on how to manually implement them. So if you want a different behavior, then you have to. I mean, if you want a different implementation, maybe you don't have to use the derived uh, syntax, right? So you can. It's a trick, right? You can just implement it yourself, then. But I think that's what they're saying. But I'm saying you don't have to use the derive anymore, right? But anyway, okay. I guess they're saying that you can still use the derive, but maybe there's a way to specify how that would be. The trait listed. mm, Wait. Okay. The traits listed here are the only ones defined by the standard library that can be implemented on your types using derived syntax. Other traits defined in the standard library don't have sensible default behavior, so it's up to you to implement them in the way that makes sense for what you're trying to accomplish. Makes sense? An example of a trait that can't be derived is display, which handles formatting for end users. You should always consider the appropriate way to display a type to an end user. What parts of the type should an end user be allowed to see? What parts they find relevant? What format of the data should be most relevant to them? The Rust compiler doesn't have insights, has this insight, so it can't provide you appropriate default. Okay. The list of derivable traits provided in this appendix is not comprehensive. Libraries can implement derive for their own traits. Making the list of traits you can use derive with truly open-ended. Implementing derive involves using a procedural macro, which is covered here. Hmm, Okay, we will get there. Debug for program outputs. The debug trait enables debug formatting in format strings. Mhm. Which you indicate by adding the column question mark within placeholders. The debug trait allows you to print instances of a type for debugging purposes. So you and other programmers using your type can inspect an instance of a particular at a particular point of the program's execution. The debug trait is required, for example, in the use of assert equal macro. This macro prints the value of instances as arguments if the equality assertion fails, so the programmers can see why the two instances weren't equal. Partial equal and equal for comparison, for equality comparison. Partial equal trait um, allows you to compare instances of a type, check for equality, and enable use of the equal and not equal operators. Deriving partial equal implements the equal method. When partial equal is derived on struct, two instances are equal if only if all fields are equal, and the instances are not equal if any of the fields are not equal. When derived on enums, each variant is equal to itself and not equal to the other variance. Okay. The partial equal trait is required, for example, with the use of assert equal macro, which needs to be able to compare two instances of a type for equality. Okay. The equal trait has no methods. Hmm. Its purpose is to signal that for every value of the annotated type, the value is equal to itself. The equal trait can only be applied to types that also implement partial equal, although not all types that implement partial equal can implement equal. One example of this is a floating point number. The implementation of floating point numbers states that two instances of the not a number value are not equal to each other. An example of when equal is required is for keys in a hash map. So the hash map can tell whether two values are the same, whether two keys are the same, sorry. Okay. Mm, I don't think I want to go through all of this now, but it's the appendix, and I think we just what we need for right now is to see which traits we can are derivable, yeah. So partial odd and odd for ordering comparisons. So I think partial odd allows you to compare instances of tags for sorting. A type that implements partial odd can be used with yeah, rectangle, brace, rectangle, okay. These operators, you can only apply the partial odd trait to types that also implement partial equal. Deriving partial odd implements the partial comparison method, which returns an option ordering that will be none. When the values don't produce an ordering, an example of okay, yeah, which is just none when it don't produce an ordering. An example of a value that doesn't produce an ordering, even though most of the values of that type can be compared, is it not a number, floating point. Calling partial comp with any floating point number and the NaN floating point number return none. Okay, when derived on structs, um, hmm, yeah, okay, when derived on structs, partial odd compares two instances by comparing the value in each field in the order in which the fields appear in the struct definition. When derived on enums, variants of the enum declared earlier in the enum definition are considered less than the variants listed later. Okay, I mean, these are details, yes, but basically what it means is you can actually derive partial odd. So basically when you derive, it's when you use the derive annotation, when you compile your code, it would be, there will be code generations for you, yeah. The partial odd trait is required, for example, for the gen range method from the rand crate that generates a random value in the range specified by a range expression. The odd trait allows you to know that for any two values of an annotated type, a valid ordering will exist. The odd trait implements compare method. It returns an ordering. Okay, so I mean we can go over each of these later, but the point is that we can also implement clone and copy, for example. I mean we can derive clone and copy. Yeah. Um, we can spend some more time to get into this one. Hash for mapping value to a fixed size. So we can also derive hash. An example of when hash is required is for storing keys in a hash map to start effectively. The derived implementation for the hash combines the results of calling hash on each of the parts of a type, meaning all fields or values must implement hash. Okay, and then what? And then default. You can also implement default. What does default do? Default trait allows you to create a default value for a type. Deriving a default implements the default function. The derived implementation of default function calls the default function on each part of the type, meaning all fields. Okay, so default is function is commonly used in combination with the struct update syntax. I think we saw the struct update syntax before. Um, yeah, we saw that. Basically, you have one struct, and then you have you have struct user, and then you create one user, and you want to update the user. I mean, you can do. No, that's not it. Where is that one? Yep, exactly. This is the struct update here. Yep, that's it. Okay, so you can customize a few fields of the struct and then set and use the default value for the rest of the fields by using, yeah, by doing this and then say default. Okay, I didn't know this. That is really cool, actually. The default trait is required when you use, so basically what that means is we can do something like this, yeah. We can say, um, yeah, I guess you can do this. We can derive default. And like we have larger now and smaller, we can say let other be rectangle, I guess, right? Can we do this and say, yep, it's right here. Default. And yeah, this is so cool. This is so cool. Okay, the default trait is required when you use the method unwrap or default on option T instances. For example, if the option T is none, the method unwrap or default will return the result of defaults for the type in the option. Yeah. Okay, this is actually very cool. I think I've used it before, but I wasn't really sure how. I mean, I saw it. I wasn't really sure exactly why. But now it's clear, right? I mean, it's so again to wrap up this part. The derivable traits are debug, partial equal and equal, and we also have to know like why we need them or what we need them for when we need them as well. Yeah. Okay. Partial odd and odd for comparison. Clone. The clone trait allows you to explicitly create a deep copy of a value, and the duplication process might involve running arbitrary code and copying heap data. Yeah. Deriving clone implements clone method. This means that all fields or values in the type must also implement clone. An example of clone is when calling the to_vec method on a slice. Slice doesn't own the type instances it contains, but the vector returned from to_vec will need to own its instances. So to_vec calls clone on each item. Mhm. The copy trait allows you to duplicate a value by only copying bits stored on the stack. No arbitrary code is necessary. The code doesn't the code the copy trait doesn't define any methods to prevent programs from overloading those methods and violating the assumption that no arbitrary code is being run. That way, all programmers can assume that copying a value will be very fast. You can derive copy on any type whose parts implement copy. Okay. Copy must also implement clone because a type that implements copy has trivial implementation of clone that performs tasks as copy. The copy trait is rarely required. Types that implement copy have optimizations available, meaning that you don't have to call clone, which makes the code more concise. Everything possible with copy, you can also accomplish with clone, but the code might be slower or you have to use clone in places. Yeah, so I mean we've seen all of this. So that's for derivable traits. We just took a quick glance at derivable traits. And what we needed to see there was about partial equal and debug mostly. So adding custom failure messages, I think we can wrap up with this one here. Adding custom failure messages, you can also add a custom message to be printed with a failure as optional arguments to the assert, assert equal, and assert not equal macros. Any arguments specified after the required arguments are passed along to the format macro. So you can pass a format string that contains these placeholders and values going to the specifiers. Custom methods are useful for documenting what an assertion means when a test fails, so you have a better idea of what the problem is in the code. For example, let's say we have a function that greets people by name and we want to test that the name we pass to the function into the function appears in the output. So I have a greet, and this is it. This is the string. Now we want to test that greeting contains name. So greeting and then the name, and then we can do result contains. But what about the okay? I mean, this is regular, yeah. So the requirement for this program hasn't been agreed upon yet, but we are pretty sure that hello text at the beginning of the greeting will change. We decided we don't want to have to update the test when the requirements change. So instead of checking for for the exact equality to the value returned from the greeting function, we just have said that the output contains the text input of text parameter. Okay, yes. Now let's introduce a bug into this code by changing greeting to exclude name, like so. Uh-huh. It panics. But when it panics, you don't really know what it's not clear to see it, right? You just see the greeting contains name, failed, and then greeting contains name panicked. The result is just the result just indicates that the assertion failed and the line which the assertion is on. A more useful message, a failure message would print the value from the greeting function. Exactly. Let's add a custom failure message composed of a format string with a placeholder filled with the actual value we got from greeting function. So basically, we have something like this, and then you'd assert, and then you pass. What is the second parameter you pass? Is that a hold on? The custom message. Any argument specified after the required arguments are passed along to the format macro. So you can pass a format string that contains angle brackets, placeholders, and the values to go into those places. Nice. So that's what we're doing here when we do this. Yeah. So okay, can we do can we do this then? Yeah. Okay, so does not implement display. Oh wait, we cannot implement. Oh, we can't derive display traits. I think we saw that, right? I think that's what they said here. I think you talked about display that it's not something. An example of a trait that can be derived is display. Yeah. The reason is because you need to know. I mean, it's gonna be different for. I see. Yeah. So for that reason, okay. I just want to see. Okay. I want to see. I just want to see what can be passed to the passed as arguments right next to. So we see failed larger 50 and smaller 10 not equal. Okay, so that's fine. So I can pass in stuff just like I will pass stuff to format. And I also saw that you can do, I think it was like, so yeah. Okay. All right. Okay. That's fine. Checking for panics. Okay, I think we can continue from here. We can continue from here. Um, so this is about tests, and for quite frankly, I think I looked at tests before, but it's also good for us to go to learn more about it. Yeah. All right. See you on the next one. Have a good evening. Bye.